Hi, everybody. I hope you can hear me well. Um, I'm Xavier Tissier, the Director of Operation at Vibrant Village Foundation. And it's the first time we are hosting a session like this. I hope we can organize more learning sessions in the future if there are more interest, with a goal to support you beyond funding. And today, so we are hosting Roland Bunch. I sent you his background, his impressive background and work on agroecology in Africa. So I will not necessarily repeat what I already sent you. And today we have about 25 attendees from 9 different nonprofit organizations from Ghana, Malawi, Senegal, and Uganda. So very diverse. And just to remind everybody about some Zoom tips that I sent in my email, if you could, mute yourself when you don't speak, and don't forget to unmute yourself if you want to speak. And Roland is happy to answer any questions as they come. So don't wait for the end of the presentation. Just speak up as we go in the presentation, and Roland prefers to do it that way. Now I will turn to Roland, and I will be silent facilitator in the background. So Roland, go ahead.
Okay, well, good morning or good evening or whatever it is where you are. um, yeah, let me just say, first of all, to give you a little background, I have been working with green manure cover crops for almost 40 years. Um, a lot of that in Latin America, but also the last 15 years in Africa. I've been to, I've worked in northern Ghana, I've worked in Uganda in several parts, and all over Malawi. So I know most of your areas, and I haven't really worked with green manure cover crops in Senegal, but I have worked with them in northern and central Mali. So the climate there and so forth is pretty much the same as it is in Senegal. So I think I do have information that will be relevant to each of the areas where you're from. And like Xavier said, uh, we invite questions as we go, because often the answer to the question is right in the photo we're looking at. If we wait until the end, then it's going to be difficult sometimes to explain or let you really see what the situation is with whatever system we're talking about. I've worked with about 35 different species of green manure cover crops, and I've visited farmers who are using another 30 or 35 different green manure cover crops. So I know most of the ones around the world that we know of that are being used. Um, but most of my recommendations will deal with only about 6 or 8 different species, because first of all, it's hard to get the seed of some of the others. And secondly, they tend to be the best. I mean, there are some that are best for one situation, some that are best for another. And in fact, that's the most difficult thing for you as program people or extensionists, is to figure out which are the 2 or 3 systems that would best work where you are, which species and how to use them. After that, things get pretty simple. Once you've decided on 2 or 3 species, the farmers can try them out, decide which one they like best, and they're in 5 minutes you can tell them everything they need to know about that particular system or that particular species. So let me go ahead and get started. The first photo here, we can see a farmer. Actually, he's a smallholder farmer from the country of Honduras in Central America. You can see he's very happy with his maize. He's now producing. He's showing us in his right hand the 2 large ears that he now produces on each maize plant. On the left, the smaller ear that he used to get on each maize plant previously. So his harvest is increased by about 3 times. That's a very common occurrence with green manure cover crops. It usually takes about 4 or 5 years, But usually after 4 or 5 years, and it's a very cheap process, you're getting close to 3 times what you used to harvest. In other words, in Africa, the maize harvest will usually go from somewhere around 1 ton per hectare or a little less, and they'll be harvesting close to 3 tons per hectare within about 4 or 5 years. By the second or third year, they should be producing double what they did traditionally. So the benefits from these, and we'll talk about more benefits, but the benefits from these green manure cover crops are sometimes hard to believe. Now, one of the other things I love about this particular photo is that in Honduras, just like in most of Africa, almost all the young people are moving to the cities because they know their land and their crops are getting worse and worse, and they just don't see a future in the villages. I know that, for instance, in Africa right now, the average age of a smallholder farmer in Africa is now somewhere between 51 and 54 years of age. All the young people have gone to the cities. But in this case, on this farmer's land, his son is still there. His son is sitting there, and he plans to stay there, get married in the village and so forth, because he knows that his father's land will be at least as good or even a little better in the future than it is right now. So that's pretty revolutionary, and that's one of the things I feel best about in everything we do. Not only do people have enough food, because producing 3 times what they traditionally do means they almost always have enough basic grains for the whole year, but it means their children can stay in the village and don't have to go to the city. So anyway, the name of this presentation is the use of green manure cover crops to fertilize the soil and end the droughts. Now, I know ending the droughts sounds pretty radical. I didn't even believe that 10 years ago. But as we've worked more and more in African areas where there are severe droughts, we have found that the droughts are almost always caused more by the soil conditions, the fact that the soil has become hard and all the water runs off instead of going into the soil. In fact, experiments in Malawi have now shown, scientific experiments have shown that under the conditions of 40 or 50 years ago, the soil had enough organic matter so that 60% of all the rainfall was going into the soil. In other words, it was what we say infiltrating. Now, in Malawi, in the vast majority of cases, only 10 to 20% of the rainwater goes into the soil, and all the rest washes off. In fact, in many countries like Malawi, we have floods and droughts the same year. Farmers will ask me, if we're having droughts, why are there floods? And the fact of the matter is, it's not lack of rainfall, it's lack of the ability of that rain to get into the soil, because there's no organic matter in the soil anymore. Okay? In other words, when people used to fallow, when they used to let a forest grow on their land, then the soil took in a lot more moisture and stayed moist longer, just like forests do today. But once your soil has no organic matter in it, because we haven't been doing fallowing anymore, we haven't let the forest grow, then what happens is most of the water runs off, and we experience really bad droughts. Okay, next. Xavier? Okay. Causes of the droughts. First of all, climate change. Climate change is having some impact. Climate change mostly affects droughts because it tends to make it rain very heavily 1 or 2 days, and then it will stop raining for a week or 2 weeks. Or it will rain very unpredictably. We don't know when it's going to rain. We think the rain started, we plant our crops, and the next 2 weeks it stops raining, and so our seed dies. This is the sort of thing that happens all over Africa now, at least in the droughtier areas. I think in all the areas you're working in. Is anybody working in an area where you don't have droughts? Wave your hand if you work in an area where there are no droughts. Okay, that's I can't see anybody. Okay. So that's the impact that climate change has. But the tremendous droughts that we're having now and have had in the last been getting worse over the last 20 or 30 years is more because people have had to stop using forest fallows. They can't let the forest grow on their land because they don't have enough land. If they let 3/4 of their land grow in forest, they won't have enough land to produce the food they need. So much more important, number 2 here, much more important, the end of fallowings or slash and burn agriculture has dramatically reduced the quantity of organic matter in the soil. This factor has reduced the rainwater infiltration from about 60% down to less than 20% in many, many areas. And that's the real reason we have these droughts. And that's why they're getting worse and worse, is because our soil has less and less organic matter in it. Okay? Okay, next. What can be done? The only feasible solution, the only cheap solution that the vast majority of farmers can afford to adopt for increasing the organic matter in our soils is to use green manure cover crops. What we're going to talk about today. That's really the only way. And why do I say that? Smallholder farmers do not have enough animal manure to do this. For 2 hectares of land, it'll take about 20 animals, 20 cattle, well fed, to have enough manure to fertilize that land and make it a little better. Now, if you have 20 cattle, you're no longer a poor farmer. You know, I mean, the vast majority of farmers just don't have that much manure. Furthermore, it's a lot of labor to apply it. And that's only if they could get enough plant material so that their cattle would be well fed. Green manures, on the other hand, can produce more than 30 tons per hectare per year green weight of organic matter. In other words, for instance, how many of you have ever seen a farmer even produce in 1 year 10 tons of compost? I'll bet none of you ever have. I've only seen that once or twice, okay, in 30 years. Okay, and yet a green manure cover crop, if it produces decently well, will produce more than 30 tons per hectare per year of green organic matter, okay? So we're talking about a tremendous, much more organic matter than you're going to get with either animal manure or green manure cover crops. Or compost. Another problem with compost is that you're not really creating organic matter, you're processing it, which means that you've got to collect that organic matter somehow, somewhere. And if everybody in the village is doing that, the animals are going to be left with very little to eat. Okay? Green manure cover crops actually produce new organic matter. They aren't taking organic matter from somewhere else in the village. They're producing it out of nothing, out of just, their own growth. So, the green compost and animal manure should always be used if farmers can have the time and the energy and so forth, and the manpower or woman power to create it and spread it and so forth and so on, apply it to the soil. But green manure cover crops can easily produce 30 tons per hectare per year, which means it's enough to improve the soil each year as you're farming, and it doesn't require transportation, and it's already even spread across the field where you're going to be farming. So you have it, you don't even have to spread it across your field. It's already spread. Next. Okay, those of you who are agronomists or who have read about agriculture probably have no idea of what organic matter can do for the soil. I only am aware of it because of this experiment done by a farmer in Honduras. He didn't believe what we were saying about what organic matter could do for the soil. And in fact, at that time, this was in 1981, at that time, we didn't even realize ourselves how much organic matter can do for the soil. But this farmer, since he didn't believe us, he made about 16 compost heaps. And he put it on the left-hand side of this photo and you know, the rest of the field over there. 16 compost heaps. I mean, that was a lot. And then he planted his field. He planted all the field, the whole field, with the same seed and on the same day. Now you can see where the arrows are. Those are maize plants. Those maize plants were planted the same day, obviously in the same field, as the maize plants on the left that are about 2 meters tall. Okay, what's the difference? From that row, and then you see another row of maize that's a little bit yellowish and only half as tall as the other maize. That's that way. It didn't get any compost, but it sent its roots over and stole some of the compost from the other maize. But what you see here, the difference between where the arrows are and where the maize is growing clear out of the top of the picture, the only difference there is that on the left, the farmer put in a tremendous amount of compost in his soil. On the right, he didn't do that. Okay, so on the left, the soil was turned over because in order to put the compost in, and the compost was applied. On the right, he just planted his maize traditionally. So you can see there's a tremendous difference. And all that maize was planted the very same day. This is the tremendous difference that lots of organic matter can make. Now, we won't see that much difference after the first year of planting green manure cover crops because we won't be getting that much organic matter. But still, we will see a difference. And by the third year, we should have at least a doubling of the original yields. And like I say, by the third or fourth or fifth, by the fifth year, you should see maize looking like what's on the left if things are going well. Okay? So large quantities of organic matter can do a tremendous lot. We won't see this change in 1 year, but we can see it in 3 or 4 years, and the cost is virtually nothing. Next.
Roland, you have a question in the chat room. I don't know if you
see
the chat room.
Yeah.
From Kamoga.
I don't hear him or her.
Oh, it's in the chat. So Kamoga, do you want to unmute yourself, or should I just read the question?
Thank you very much. I agree that smallholder farmers do not have enough animal manure, but still their production abilities are limited by lack of land, lack of labor. I wanted to know, how do we help them increase on the materials for green manures? What can we do to help them improve on the amount of green manures they can use?
Okay. Basically, that depends on the particular situation you're in. Usually, the only thing we have to do is get seed. We may have to get it from within our country, or we may actually have to get it from a nearby country. So that is usually the one problem we really have to deal with, is getting the seed. Now, in some cases, in a few cases, the seed's already available. For instance, which country are you from?
Uganda. The country is Uganda.
Okay, northern or southern or east
yes,
or
Uganda.
west? What? Which part of Uganda? North, south?
Central, mainly central Uganda.
Okay. Now in central Uganda, for instance, lab is one of the species I'll be talking about. It's called njahe in Swahili, and probably you can get it there in a market in the capital. If not, it is sold in the let's see, northeastern corner of Uganda, because lab is very, very common in Kenya. The Kikuyu people couldn't live without it. So, you can usually get seed for lab. Jack bean, you'd probably have to go to a program that's already using it. I know some programs up in northwestern Uganda, which already have jack bean. So you'll have to look around. Glycyrrhizia is another one I will be talking about a lot. If you can't get it in Uganda, it is available in many parts of Kenya. It's also available in Tanzania, but in the Northwest, that's a long ways away from Uganda. But Glycyrrhizia is quite common. For instance, in Nairobi, you'll see it growing along the streets sometimes. So, you know, some of these seeds you're going to have to look for. Others, like Lab, I think you're going to be able to find probably right in the market,
Yeah.
in the capital.
Yeah, we can find Lab.
Okay.
Yeah, we can find that. Thank you very much. Thank you very much for that.
Now, after that, basically what we usually do is, excuse me?
I wanted to just remind you that probably some farmers would prefer seeds that can also produce food, because now, like the Lab can improve green manure, the jack bean, because they are not normally eaten, and for them, because they don't have a benefit as food directed to them. They prefer seeds that probably can do the green manuring and at the same time food. But at least I know these plants, we can say we can incorporate them in our work.
Yeah, you're absolutely right. The main thing people are going to want is that they also can eat it. And they can do that with things like cowpeas or, you know, that they already eat. But actually, Lab is edible. Usually you have to learn how to cook it because it has a little bit of a bitter taste. But the Kikuyu people, for instance, in Kenya, who live in Nairobi and north of there, they eat Lab all the time. And in fact, I had a very interesting experience in Kenya, but right near the Ugandan border, between Kisumu and the Ugandan border. There were about 1,000 or 2,000 farmers who had recently learned to use Lab, and the program found out that one of the wives of one of the Luo people who lived there was in fact Kikuyu. So they had her come and cook some Lab for the leaders from the different villages one day when they were meeting for classes. And they loved it because she knew how to cook it. And as a result now, well, about 6 months later, I was in the same program again, visiting it. And they asked me when I went out to the villages to please buy some Lab seed because there was a tremendous demand for it. They didn't have enough. The program didn't. So I went out to the villages, and every village I went to about 7 different villages. In every village, they said, well, I'm sorry, we don't have any extra Lab because we eat all the Lab we produce. So they wouldn't sell me Lab. So, you know, I mean, that's about you know, when you're offered a good market and you still want to eat it instead, that's a pretty good sign that people like it. But I would suggest, frankly, if you don't have any information on how to cook it, and it should be from a Kikuyu because they really know how to cook it. Write me an email, and I'll get in contact with the people in that program and send you a recipe. Okay.
Well, thank you. All right. Thank you very much. Yes.
Another thing with the Lab, and this is probably as important as the leaves, as the seeds. The Lab leaves are also very nutritious and edible. They have a lot of protein because they're from a legume, but they also have vitamins and minerals that the seeds don't because of the fact that they're dark green leaves. So the Lab leaves in some areas now of Malawi and Mozambique, people are eating the Lab leaves. They like them. They cook them just the way they cook other things like cassava leaves and so forth. And furthermore, the people in Zambia found that they could dry the leaves. It's a very simple process. They could dry the leaves and store them in fertilizer sacks, old fertilizer sacks. And those leaves would last all year long. So they basically had a very high protein, high vitamin and mineral food that was available all year long and basically free because it was just a byproduct of growing it was just part of growing the Lab. You know, they could just harvest leaves, the fresh leaves off the Lab over a period of 2 or 3 months And that way they had high protein food all year long. So, you know, these sorts of things these are the sorts of things you need to learn. And, you know, you can show people how to grow these leaves. And by and large, in most of the places I've been in Africa, they like the lab leaves after they've prepared them. Okay, next, yeah. Okay, what am I talking about? Green manure cover crops. What's that mean? A green manure cover crop is any plant. It can be a tree, a bush, a climber, a crawler, or even waterborne organisms, although we don't use those much in Africa, that farmers use, among other reasons, to fertilize the soil, control weeds, or overcome droughts. In other words, that's why there's over 100 species of these things, because they are so there are so many of them. They can be trees, bushes, climbers, crawlers, etc. And any of these that farmers use to fertilize the soil, control weeds, or overcome droughts, we call a green manure cover crop. Next. Okay, what are the advantages? There's a long list of advantages, and that's why farmers love these things. By the way, I constantly hear from African agronomists that smallholder farmers don't want to change. They don't want, you know, they don't easily accept new technologies. Once you learn about green manure cover crops and learn how to grow them, and to some extent learn how to convince people they should, they are incredibly popular. We have a program right now in Malawi, in southern Malawi, where we started out with about 100 farmers planting Gliricidia trees, which is a green manure cover crop. And now, 2 years later, there are over 1,000 farmers that are planting them, and they're planting them on. They've planted this year. They planted over 100,000 trees in their fields. And you know, farmers, you know, like in West Africa, they don't like planting trees in their fields, but they have found that these trees, instead of reducing their yields, tremendously increase them. So, you know, in 2 years, we've gone from about 100 farmers to well over 1,000 farmers. And this last year, well, no, excuse me, in the last 2 years, they planted over 100,000 trees, 20,000 trees last year and 100,000 trees this year. Okay, so these are tremendously popular. The main reason is that they control the droughts. Farmers are increasingly worried, as you probably know very well, about the droughts. They're really scared because a lot of them realize, or are beginning to realize, that these droughts are going to end their life in the villages. They're all going to have to go to the cities, not just the young kids. And so they are tremendously interested in anything that can change that situation. And one of the ways we convince them is to talk about the forests. I mean, almost all the villages have at least some forest because that's where they get their firewood. And they know that in the forest, if they haven't cut down too many trees, the soil stays moist and nothing dies. You know, even those bushes, they don't die during a drought. They're growing very well in the forest. And so what we tell them is that green manure cover crops are the way we can make our soil in our fields just like the soil in the forests, so it won't dry out. Okay? And that's basically what we do is we go out and we talk about the forest, and we tell the farmers that what we're going to do is make a forest out of their fields, but a forest where you can still grow maize and your other crops. And believe me, after 20 minutes of talking with the farmers, at least in Eastern Africa and Southern Africa, after 20 minutes of talking with the farmers, they're asking us for the seed of the green manure cover crops. Are there any questions about that? Okay, that's probably the most important thing I'll tell you. Talk about the forest and the way the forest stays moist and the little plants don't die. And that's the way you convince people that green manure cover crops can be of use to them. And that green manure cover crops can, in fact, increase their yields and reduce the problem of droughts. Okay, number 2, these same plants can often produce a large quantity of additional food rich in proteins. If we can, that's the way to do it. Now Now, jack bean, for instance, which is probably the best green manure cover crop we have in terms of withstanding the droughts, not having a problem with droughts, and in terms of producing lots of nitrogen and lots of organic matter. The problem is you can't eat it. There's nothing on the jack bean plant that we recommend people eat. So, you know, people have to decide which they're going to do. Usually what farmers do in areas that are really droughty, where you have very serious droughts, is they'll plant the jack bean together with their millet, usually, like in northern Mali. They'll plant the jack bean together with the millet. After 2 years, the soil has improved so much and has become less droughty, so then they can plant lab beans. They can start using lab beans, which then they can eat. But this is one of the major things farmers will ask is, can you eat it? And in the case of jack bean, you can't. In the case of lab beans, you can not only eat it, you can eat the leaves too. 3, combined, these two factors can end hunger among the vast majority of farm families in the developing world. And this is true of Africa as well as anywhere else. I think most of you probably know that farmers traditionally are harvesting maybe enough maize for 6 months or 8 months or 9 months of what their family needs to eat. That means if they double their traditional harvest, they have enough maize for all year long. If they triple their harvest, they have a lot of maize left over that they can sell in addition to all they need to eat during the whole year. So basically, by using green manure cover crops well, if they've learned how to do it right, then in 3 or 4 years, they no longer have to fear going hungry. Okay, and that's a tremendous change in their lives. 4, they can also help reduce the labor needed to control weeds. Some of these green manures, like the lab and the jack bean, will control weeds quite well, which means you have to weed once. You have to do the first weeding on your maize or cassava, but the second, or in the case of cassava, third weeding, you don't have to do anymore, because the green manure cover crop will have grown up enough to completely compete and choke out any new weeds that start growing. So you tremendously reduce the labor. Also, and a lot of that labor is labor that women have to do, which is really important if you're trying to help women have less labor. The third thing is, and of course, the second weeding of maize is usually done right during the hunger season, which means women are not only doing a tremendous amount of work out in the fields, they're doing it without having had enough food to eat. That's women are extremely happy when they find out that they can use these things to control weeds like that. And in fact, I will, if a village asks me to come and talk about green manures, I will always tell them that they should have women present as well as men, because the women are usually even more interested in green manures than the men are. Partly because it reduces their labor, and partly because they're the ones who have to feed the children, and then they have enough food to feed their children. They don't have to tell their children, sorry, we don't have any more food. Another major source of labor for village families is that they have to go out, the women have to go out and collect the wood, the firewood. Well, if you have gliricidia trees growing right in your field, then the women don't have to go out and walk 2 or 3 or 4 kilometers to get firewood. They have it right in their fields, and furthermore, it has to be pruned, which is men's work. So the only thing the women have to do is pick it up off the ground and carry it to maybe half a kilometer to the house. Yes, Xavier.
Yes, so there are a few questions also for you.
Good, okay.
Palomi has a question first, and then Habib too.
Thank you, Javier. So Roland, my question is, I work for a nonprofit that works in Senegal, and our community farms are producing vegetables. We have irrigation, so they are producing year round, but they are producing vegetables literally in the sand. So they use compost a lot to kind of make holes in the sand and use compost as the bed for these vegetables. So my question is, would these green manures work for vegetables as much as they work for the basic grains that you've been talking about? And then, of course, would it work in sandy soil like what we have in our community farms in Senegal?
Yeah. Okay, sandy soils make it a little more difficult to use green manure cover crops. And the other problem that we have with using them with vegetables is that they grow up and cover the vegetables if you intercrop them. So there's several different ways you can use them. And by the way, green manures do work with vegetables. In fact, they create a better kind of fertility than even synthetic fertilizers. They basically do the same thing that animal manure does, except you don't have to collect the animal manure. So one of the best ways, which of the vegetables do they most grow?
They grow eggplants, tomatoes, turnips, okra, a variety of vegetables.
Okay, I assume they're rotating them. They'll plant tomato in a field one time, and then the next time they'll plant eggplant or something else, right?
Yes.
Okay, so then there's a very good way then to use green manures in that situation. What I would recommend is to use jack bean. Jack bean has the qualities that it grows very well in very poor soils. I've seen jack bean grow very well even in western Zambia, where they have what they call Kalahari sands, which are white sand that goes down 3 and 4 meters. There's nothing but white sand, you know. I mean, it's just amazingly bad soil. And the jack bean grows very well. So I'm sure they'll grow well where you are. The second thing about jack bean is it withstands drought. I mean, if you have a sandy soil like that, you probably have a serious problem with droughts. And you don't, well, of course, you're irrigating your vegetables, so there's no problem with drought. What I would do is intercrop the jack bean right in among your tomatoes and eggplants, not the others, because like turnips, they'll get covered by the jack bean, and the jack bean will snuff them out. They'll kill them. But if you grow the jack bean in among tomatoes and eggplants, those plants are tall enough so that all you have to do is you plant the jack bean at the same time as you do your tomatoes and eggplants. You plant maybe 2 or 3 jack bean seeds per square meter. So it's quite a few, but you plant them between the rows. And then when the jack bean gets tall enough, usually after about a month or a month and a half after planting, when the jack bean gets tall enough so it starts bothering your tomatoes and eggplants, you prune it. You prune it down so that all of the jack bean is about 30 or 40 centimeters tall. In other words, you cut it down to probably about half the size that it has become. So it's about, like I say, it's about 20, 30 centimeters tall. And then it won't grow up tall again. It will grow sideways, so that it'll grow right there among your tomatoes and eggplants. And the first year you may have a little bit of reduction because of competition with the jack bean. You may have a reduction of maybe 10 or 20% of productivity, but not more than that. The second year, your tomatoes and eggplants will probably produce 50% more than they did traditionally, and by the third year, maybe twice as much. So it can be a really wonderful thing for vegetables. Now, but you have to, I would suggest that farmers only do this on one small part of their tomato fields or eggplant fields, so that they make sure they know how to do it. They make sure they've gotten it right. And also they can see whether they like the idea or not. But do tell them that the main impact, the main benefit, the main advantage of planting these won't show up until the second year, not the first year. Okay? But I think you'll find that farmers will love this practice. It's done there's a huge area of Mexico now where almost everybody does this, and also in Paraguay, it's in South America. It's a traditional practice that tens of thousands of farmers use every year when they grow cassava. They do this with jack beans and when they're growing cassava. So do it with, like I say, with tomatoes or eggplants, the tall plants. Don't do it with the small plants, but the small plants will benefit when they're planted in that same land after the jack bean has been taken out. Okay, do you understand?
Yes, I do. Thank you so much.
Okay, you're welcome.
Roland, so we have 3 more questions. We also have only 15 minutes left in the presentation, so I'll let you manage if you want to continue the presentation or respond to.
I think we only have 15 more minutes.
We have 15 more minutes, yes.
Yep. Okay, well then let me continue the presentation. Excuse me.
All right.
Yeah, okay. Next. Okay. Green manure cover crops can reduce the impact of droughts by about 80%. After 6 years, we find that the farmers are producing 3 times what they used to produce in a good year, and 2.5 times what they produce in used to produce even in a good year during a drought year. So the advantages of this are just tremendous. 6, they can sequester carbon in the soil. I won't go into that because that's basically a benefit for everybody in the world, not so much just the farmer. 7, they can produce a good deal of other crops, such as firewood. In the case of Gliricidia, for instance, they can produce medicines, year-round fodder for animals. The lab bean is a very good fodder for animals, and so forth. Next. 8, by shading crops and increasing soil moisture, and this is what the Gliricidia does, or the trees that we use, they can go a long ways toward cheaply protecting our crops from global warming. In other words, this is a very efficient form of what a lot of organizations call climate smart agriculture. 9, they can reduce overall costs by eliminating or reducing weeding labor, eliminating or reducing tillage. After 2 or 3 years, with most green manure crops, you never have to till your soil again. You never have to plow it or hoe it. It's so soft that your plants will grow without any kind of plowing. Okay, next. Okay, here's a field. This actually happens to be in Central America, but the same thing will happen in Africa. Although in West Africa, you don't have hillsides like this. But the top half of that field in the background, where it's dark green and the maize is almost 2 meters tall, that's had a green manure for 2 years. The lower half of that field, where the maize is very yellow and short, maybe a little over knee high, the only difference between those 2 fields is that one of them had a green manure for 2 years and the other didn't. Next. Here are the same 2 fields. The woman on the left is the owner of the field. And you can see that behind her, that maize is going to produce very nicely, probably 2 or 3 tons per hectare of maize. The maize below her is hardly going to produce anything. And now, usually that takes more than 2 years. This was a particularly good case. Usually to get that kind of an increase, it takes 4 years or maybe 5 years. But it's almost guaranteed if they're using the green manures right. If they aren't getting that kind of an increase over 4 or 5 years, then something's wrong with what they're doing. Next. Okay, now this is the photo that 10 years ago I wouldn't have believed. But now I do, because I've seen it. I've seen this change in Mali, I've seen it in Malawi, I've seen it in Mozambique, and I've seen it in Madagascar. This photo happens to be from Madagascar. This is a maize field. They had a bad drought. You can see both the maize and the cowpeas below it are not doing very well. The maize is, probably they're going to be lucky if they get even 800 kilos per hectare out of that maize. Next. Next. Okay. This maize field, whether you believe it or not, it's the same field, but in this field, they've grown the cowpeas. Now, this is a 9-month cowpea, which we can't get in West Africa, so it's a little bit different than what we can do there. But the same This will happen with Lab or Jack Bean or any of the other green manures. This field is the same field, planted the same time. The only difference between this and the previous photo is that in this field, they've planted the cowpea for 6 years. In the previous photo, that was the first year. In other words, this has 6 years of impact from the cowpea. The other one is only 1 year. Now let's go back back to the last photo. Okay, if I'm now going to show you proof that what I'm saying is the truth, that this is the same field, the same year and everything. If you look up in the sky, on the right-hand side, there's a roundish cloud, and then to the right of that, right in the corner of the picture, there's a larger cloud that's pointed, okay? Now, next photo. Okay, you'll see those two clouds halfway across the sky now. About halfway across on the left side is the round one, and just behind that is the pointed one. Okay, so these two photos were taken within half an hour of each other. They were the same field, the same woman is the owner of the fields, and the only difference between this and the last photo, and this field will probably produce, I don't know, looking at it, probably 3 tons, close to 3 tons of maize, maybe 2.5. This field, the only difference between this field and the last field is that this field has had 6 years of green manure cover crop. The other field has only had the first year. You can see that there was a drought here because where the vetiver grass is, where that grass is, you can see some of the leaves are curled. They've suffered from drought. But the rest of the maize most of the rest of the maize has very flat, dark green leaves. Those plants have not suffered from any kind of drought, okay? And that's because of the 6 years of green manure, putting all sorts of organic matter in the soil. So all the rain that fell here, or the vast majority of it, fell and went into the soil rather than running off, okay? Now I wouldn't have believed that 10 years ago, but I've now seen it, like I said, in 5 or 6 different countries in Africa, and I know it's going to work elsewhere. You can get tremendous increases in yields, even during the droughts, if you do things right. Okay, tropical green manure cover crops are able to fix a lot more nitrogen than any of you agronomists ever saw in a textbook. These are the nodules, the nitrogen fixing nodules. These are producing fertilizer. I mean, these are basically the same as chemical fertilizer, if like urea, which only has nitrogen. And the reason there are so many on each plant is just because tropical legumes produce a lot of nitrogen, more so than any of the photos you'll ever see in a textbook. Now you won't see this many in a field because this particular plant, the farmers were just doing an experiment. They cleared everything around it, so there were no weeds for like 3 meters away. And so they got a lot more nodules. In a field where there's competition with the crops and there's competition with the other mucuna plants, you'll see maybe one of these sort of balls of nodules. But in any case, these green manures will fix more nitrogen than anyone would ever use using synthetic fertilizer, using chemical fertilizer. So we don't have to worry about using chemical fertilizer if we're using green manure as well. Now, it's always good to put some animal manure on if you have it, and even well, frankly, if farmers also have vegetables, I would put all my animal manure on the vegetables, not on the maize, and let the green manures fertilize your maize. Next. Okay, the most important rules for managing green manure cover crops efficiently. The first one is the golden rule. Green leaves must be applied to the ground at the time that farmers plant their next crop. This means that the green manure has to live through the dry season. That's one of the problems with mucuna. A lot of people know about mucuna. They think it's the greatest green manure in the world, but unless you have irrigation, you're going to have the problem that the green manure, the mucuna dies when the rains stop in most of Africa. Now, this is not true of Central Africa where they have lots and lots of rain. But in all the areas where you people are working, you're going to have their green manure is going to have to grow through the dry season. That's why we choose lab or jack bean or some of the or Ligularicidea, because these plants all grow through the dry season. Now, the problem that brings is you've got to somehow control the free grazing animals. And but you know, farmers will realize if they're using green manure cover crops, it's well worthwhile to make living fences. They usually know how to make a living fence. That takes quite a bit of labor. But if they can get their green manures to grow through the dry season and they apply green leaves or almost green leaves to the ground when they plant their maize, they will get maximum benefit from their green manure. Two, farmers, and that thing of having a fence around it. In Malawi, for those of you from Malawi, we have a plant that will grow into a wonderful fence. Within 1 year, it'll keep out the cattle, and it goes on growing for 80 years. So you don't have to replant it all the time. All you have to do is prune it and keep the fires during the dry season away from it by clearing an area next to the fence. But that plant is called monkey thorn, the monkey thorn tree. It's now grown in many parts of southern Malawi. If you don't know about it, go down to Blantyre and get some seed. You'll have to probably buy it from a group there called Imagine Africa that has its offices in Blantyre, and let them know ahead of time so they will have some seed for you. But this monkey thorn is now known in large areas of southern Malawi. And like I say, you plant it once, after 1 year, it'll keep the cattle out and the goats out, and it'll grow for 80 years before they have to replant it. It's an amazing fence, and it doesn't take up very much space. Okay, second, the farmers are presently using more than 100 species of green manures cover crops. The difficult thing is finding out which species will work best in our particular situation. One of the ways of finding that out, if VVF can maybe help you, to get this book. It's a book I wrote, about 200 pages, and it's called Restoring the Soil. And this will tell you everything you need to know about green manure cover crops. Okay. Okay, next. Okay, unless they also produce food, we cannot grow green manure cover crops in place of farmers' food crops. In other words, we have to grow the green manures either below them, above them, as with trees, intercrop with the crops already grown in farmers' fields, or grow them during the dry season, or a combination of these processes. But we can't say, okay, don't grow maize this year on this piece of land, grow a green manure cover crop. Farmers will never do it. They have to be able to grow their crops all the time in addition to the green manures. 4, imitate the forest. Over a period of time, over the next 10 years, hopefully these fields will have 2 or 3 different green manure cover crops, maybe 4 or 5 in them, along with our crops, and they will begin to look like a forest. In other words, the more our fields look like a forest, but can still grow maize or millet or sorghum or whatever farmers already want to grow, or cassava, or even vegetables. Now, in vegetables, we aren't going to get to anything looking like a forest. But with these taller plants, farmers can wind up almost with a forest with space in them so they can still grow maize and produce more maize than they ever did before. Okay, 5, or next photo. Okay, we're out of time. So the next photo. Okay, here's jack bean being grown with maize. This is in a part of Mexico that's so droughty that you can see almost all the maize died. Only a few of the maize plants are left, but the jack bean looks like it was irrigated yesterday. The jack bean is everything that's green under the maize. Okay, that's what will happen. The jack bean will grow through droughts that will kill all the maize. Okay, and so it's very good in droughty areas. It's very good in very sandy soils or any soil. In fact, you can grow it in soils where no crop will grow, and it will usually grow, even on what we call wastelands. You can recuperate wastelands with jack bean. If farmers have land they can't grow anything on, have them get some jack bean, and in 2 or 3 years, they'll have a field again. Next. Okay, here jack bean is being grown together with cassava. And you can see the cassava is doing very, very well. The jack bean controls the weeds, So these farmers only have to weed their cassava fields once. This is a practice that's being used in Paraguay by well over 20,000 farmers. Next. Okay, here's the lab bean. This is 2 months after the rains have stopped. You can see the maize is all harvested and dry, and the lab bean is still producing beans. You can see it up on the top of the plants. You can see the pods. That means that they will have fresh lab beans for at least 3 or 4 months. And the plant will continue to stay alive, usually, until the next, when we want to cut it all down and replant when the rains come again. That's the way we do it. We keep these growing during the dry season. Both lab and jack bean will do that, and some others. And then we plant those leaves. We put on the soil right before we plant our maize, and that way they'll have a maximum amount of fertilizer in the leaves. And also, this is good fodder. If you have more than you need for your soil, and that won't be true for several years, but if you have lots and lots of lab, you can always give some to your cattle. They love it. They will eat lab before they eat anything else, which is why you need a fence. Because if you're the only one, if one farmer is growing lab in the whole village, everybody's cattle will go and eat all the lab before they eat anything else. They love it. Next. Okay, here's Gliricidia. I've mentioned this several times. It grows very well in West Africa. I've planted it all over Mali. And it'll grow up to areas where you have even a little bit less than 500 millimeters of rain a year. And what you do is you plant either the cuttings, or you plant, actually the best thing is to plant seedlings, and you let them grow a little longer in the pepiniere, the seed bed. You let them grow until they're 1 meter tall, which means the roots are longer than you usually do. So you have to make the holes for planting the seedlings maybe 1/2 meter deep. You have to make them fairly deep, so the roots can go straight down in the soil, and the plant is 1 meter tall. If it's 1 meter tall, excuse me, yeah, if it's 1 meter tall, the plant will survive even a drought in areas where you have 400 to 500 millimeters of rain. We had in northern Mali, like this photo here, we had 95% survival rate during a droughty year. So, you know, these are very drought resistant. Then after the first year, they never die from drought, like trees in the forest. They don't die. And what you have to do is you have to prune them each year when the rains start. You prune all the branches off of them, and you prune the trunk up at about as you can see in this photo, about 1.5 meters high, just over your head, so it doesn't bother you when you're working. And then you cut all the branches, all the high branches off, except for 2 or 3. You only leave 2 or 3 branches. Each year you do this before you plant the maize. And you can see these people are planting their millet. They're planting their millet right up. You can see the rows on the ground where they're planting their crops. You can see the mounds there. And they're planting right up next to the trees. There's a row that goes right along 1/2 meter from the trees. That's because if you prune them right, like I say, you prune them once a year right before you plant your maize or your millet, your crops will grow perfectly well. In fact, they'll grow better with a little bit of shade than they do in the total sunlight. So this is the way we manage Gliricidia, and it's a wonderful fertilizer. The leaves on that tree, pound for pound or kilo for kilo, will fertilize your crops and your vegetables just as well as animal manure does, kilo per kilo. 1 kilo of animal manure will produce the same impact as 1 kilo of these leaves. Okay, I think we're finished.
Yeah, Roland, so we are reaching, I think you have 3 more slides, and we are a little bit over time.
Well, these are just advantages of the Gliricidia. We don't really have to see those. I'd rather have questions from the people if they.
Okay. So yeah, that's what I was thinking. If so, people could leave now because it's an hour. But if you have time, Roland, for another 15 minutes for question answers, then people who have questions can stay a little bit longer to hear the responses.
That's fine. I'll be here for 15 more minutes.
All right, there are a list of questions in the chat, so yeah, I will let, maybe, I think Habib had a question earlier, then Alassane also. So maybe Habib, if you want to go first.
Yeah, hello. My name is Habib. Thank you very much for the good presentation and the efforts that is going on. My question was on what are the specific examples of the green manure cover crops that are applicable to the specific locations or environments in northern Ghana? What are the specific ones, since you have experience of coming here, that can be applied?
Okay. At first, I would use either lab or probably jack bean, because jack bean does very well in poor soil. So it's good to start out with the jack bean, even if it doesn't produce food. Then once you get your soil better, like after say 2 years of jack bean, then you can grow lab beans very well. If you try growing lab beans at first, the maize stalks in a poor soil are not strong enough to hold it up and they'll fall over. So you have to be careful. But after 2 years of jack bean in almost any place you people are working, then you can go to lab bean. You can start growing other green manures. Another one that's quite popular, for instance, in Malawi, and also, in fact, it has the advantage that people already know it and eat it in most of West Africa, is the pigeon pea. I think it's called pois Congo, or pois anglais, one of those. In French. It's called, in English, it's called pigeon pea. And in West Africa, you have a different name for it, but it's a bush that lasts for about 4 years, and you get a sort of a pea off of it that people eat. Do you know what I'm talking about? Well, look up the scientific name. The scientific name is Cajanus cajan. Okay, Cajanus cajan. You know that. Okay, you're an agronomist. You know that. Okay. It's widely eaten and widely known, so people like it. Usually you can plant that even the second year, Habib. Yeah, you can plant it even the second year, and you can plant it right in among your maize. And there's one thing you need to change, because people, when they plant it, as soon as they harvest it, they usually cut it down and they replant the next year when it rains. Don't do that. When they harvest the pigeon peas, which in West Africa is usually in what, July, August, September, something like that. Leave the plant, leave it growing. Don't cut it down, okay? Leave it growing, it will continue to grow. It grows for 4 years. So you leave it there, and then when you're ready to plant your maize, about a week before you plant your maize, you cut off the pigeon pea, cut off all the side branches, and cut off the main stem at about 60 centimeters height, okay? So it's about a little higher than knee high. It can be halfway between your knee and your waist. You cut off the pigeon pea, and then it will sprout. And the advantage of doing it that way, and you do that for 3 years, then the 4th year it will die anyway, or maybe the 5th year. So you do that for four years, and the 2nd, 3rd, and 4th year, it will be totally resistant to drought, because it already has 1 or 2 or 3 years worth of roots. So it's just like the trees in a forest. It doesn't die when there's a drought, okay? So that's what you do. And each year you prune it back and cut it off at about a meter, about 60 or 70 centimeters in height. And you'll have, not only will you have a wonderful green manure that fertilizes maize, sorghum, and millet very, very well, or cassava, you also have a plant that's totally resistant to drought for 3 years. And in fact, in Malawi, some of the farmers that have been doing this for a while, what they do is they plant 1/4 of their pigeon peas 1 year, and the other 3 years, they're just cutting them off. The next year, they plant another 1/4 of their field. So after 4 or 5 years, every year, 1/4 of their field is new seed, 1/4 of their field is first year, 1/4 is second year, and 1/4 is third year pigeon pea, and 1/4 is 4th year pigeon pea. That means that even in the worst droughts, they will only lose the 1st year pigeon pea. The 2nd, 3rd, and 4th year pigeon pea, they will get a very good crop, just as if there wasn't a drought, because they already have a big root system. Is that clear? Habib?
Yeah,
Okay.
it's clear.
Yeah, that's the only thing they have to do is instead of killing the pigeon pea plant, they cut it off about 1 meter high just before they plant their next maize crop, long after they've harvested it. And that way they will have drought resistant pigeon peas for the next 3 years in that field. And people love it. It's very, very popular now in certain parts of southern Malawi. Okay, next question.
So next, Al Hassan had a question, but I'm not sure if he's still in the Zoom. So Al Hassan, are you still there? Otherwise, Idrisu, you can go next.
Yes, actually my question is the one Habib had just asked, and then I think it's clear.
Okay, okay, great. And you have
Okay, thank
pigeon
you.
peas there also? You have pigeon peas there in Ghana, right?
Yes, yes, we have pigeon pea. Yes,
Okay,
we
okay.
have
So
pigeon pea in the north.
that way they can almost
Okay.
start off. They can almost start off maybe the second year with well, you could try planting them even the first year. If people are planting them, then obviously there's enough fertility for them to grow, and that way they have food from their green manure right from the start.
And Palomi also, Palomi, sorry, had a question, but are you still here, Palomi? Otherwise, Tikale also has a question. Tikale, maybe you can go next. So Tikale question, Roland, was what is the name of a plant which can be planted in Malawi in a year and can stay for more than 8 years? I think you mentioned a plant.
What was the last part of the question?
So what is the name of a plant which can be planted in Malawi and can stay for more than 8 years?
Okay, that's the Gliricidia, the tree. The tree I showed you back about 2 photos. Now, there is one thing I should also tell you about the Gliricidia. It can be planted by stakes once you have some trees. It can also be planted by seed, but then it's less resistant to drought, so you have to be careful. Probably the best thing at first, especially if you're up in northern Uganda. She's in Uganda, Isidro, Idrisu is from Ghana. Okay, yeah.
Yes.
Yeah, the one thing I will tell you now, well, first of all, getting Gliricidia seed may be difficult in Ghana. I'm not sure whether it's available. You could find out from Kofi, you know, the Kofi, the fellow that has the experiment station there in Ghana, near well, it's south. It's in the center of the country. But anyway, if you can get Gliricidia, it would be really good. Plant it closer together than in that photo. We started in Mali planting them about 5 to 10 meters apart. And what the farmers have told us in Malawi, where they plant lots of it now, they plant, well, like I say, thousands and thousands of these trees. They prefer to plant them every 4 to 5 meters. They'll plant them 4 meters one way and 5 meters the other way, or even 3 meters by 5 meters. Now, farmers aren't going to want to do that at first because I know they don't like having trees in their fields, but have them try it out on a very small scale. You know, just have them plant 10 trees or 15 trees at that spacing, and they'll find they like it because those leaves really fertilize the soil, and the trees don't compete with their crops. And as long as they're pruning them right, the shade won't bother their crops at all either. So, but yeah, if you want something that lasts the Gliricidia will last about 30 years. So, you know, you don't have to worry about planting it again all the time. And it provides lots of firewood right there in the field. It's very nice.
So I think that was all the questions we had in the chat, Roland. There might be other questions, but I want also to respect the time. So, you know, just to I'm happy to keep the channel open if there are more questions and you can answer, but I just want to tell everybody to that I think it was a great presentation and some engagement with questions. So I'm really happy, and I hope it spark some.
Okay, I can stay here as long as there are questions. So, if people want to go on for a while longer with questions, that's fine. One more thing, Javier, please, I didn't do this when everybody was still on, but please send everybody an email with my email address so they can ask questions later. Okay.
Yep.
I won't give it now, but if you send it to them by email, then they'll have it.
Yep. Great.
So if there are more questions, I'd be very happy to answer any more.